Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down rechargeable cells from the 2025 VCE Chemistry exam. As I go through this, please feel free to correct me if you find any mistakes. All feedback from teachers, parents, and students is greatly appreciated. Question 18 explores the fascinating intersection of biology and electrochemistry. Artificial photosynthesis is a technology designed to mimic the energy conversion process of plants, but with a specific human-centered goal, producing clean fuel rather than glucose. The mechanism of artificial photosynthesis. The primary objective of most artificial photosynthesis systems is water splitting. This involves using light energy to break water molecules apart into their constituent elements. The oxidation half. Water is oxidized to produce oxygen gas and protons. The reduction half. The protons produced are then reduced to form hydrogen gas, which serves as a high-energy density fuel. Evaluating the claims. The truth in option A. In these systems, water is indeed oxidized, losing electrons, to provide the protons and electrons necessary to produce hydrogen gas. This accurately describes the core chemical transformation of the technology. The flaw in option B. Natural photosynthesis focuses on carbon fixation to create complex sugars, glucose. Artificial photosynthesis typically bypasses the complexity of sugar production to focus on simpler fuels like hydrogen or singers. The anode-cathode trap, option C. While hydrogen ions are reduced to H2, reduction always occurs at the cathode, not the anode. The energy source, option D. By definition, photosynthesis, natural or artificial, uses solar energy, light, as the power source. If it required an external electrical power supply, it would simply be electrolysis, not photosynthesis. Correct answer, A. Based on the chemistry of a nickel-cadmium (NiCd) cell, let's break down the process to identify the correct reduction half equation during recharge. Analyze the discharge reaction. The equation provided for discharge is oxidation, discharge. Cadmium increases its oxidation state from 0 to +2 in Cd, OH2. Reduction, discharge. Nickel in NiO, OH, decreases its oxidation state from +3 to +2 in NiOH2. Analyze the recharge reaction. Recharging is the reverse of the discharge reaction. In this phase, reduction, at the cathode, a negative electrode. The species that was oxidized during discharge, Cd, must be reduced back to its original state. Cd, OH, 2 gains electrons. Oxidation, at the anode, positive electrode. The nickel species that was reduced during discharge, NiO, OH, 2, must be oxidized back to its original state. NiO, OH, 2 loses electrons. Elimination strategy. If you know the reduction, during recharge, must involve the species that was at the negative electrode during discharge. A and C are immediately eliminated because they involve the nickel species, which undergoes oxidation during recharge. B is an oxidation reaction, loss of electrons, so it cannot be the answer for a reduction question. D is the only remaining option that shows a gain of electrons for the cadmium species. Question 18. Artificial photosynthesis. Water is oxidized to provide protons and electrons for H production. Answer A. Artificial photosynthesis produces H fuel, not glucose like natural photosynthesis. Reduction occurs at the cathode, never the anode. Watch for electrode traps. Solar energy powers photosynthesis. External electricity equals electrolysis, not photosynthesis. Question 13. NICD rechargeable cell. Recharging reverses the discharge reaction. Answer D. During recharge, CdOH is reduced back to Cd at the cathode. NiOH is oxidized back to NiOH at the anode. Elimination strategy. Identify the electrode species first, then check electron direction. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.